Welcome to the Humber College Student Learning Services. We are the Math and Writing Center, and the video for today we're going to talk about derivatives. Okay? So a derivative of a function is defined by a limit. Recall what we learned last time. What is a limit? It is defined as a Newton's quotient. Okay? So f prime of x, which is derivative of f at x, is the limit of this. So f of x plus h is like the increment minus fx over h, okay, and as h approaches 0. So you might learn this as like the instantaneous rate of change, right? So we have a lot of rules for derivatives. The constant rule, the constant for derivatives is also 0, always 0. The power rule is, right, this. And the constant multiple rule is that when we multiply by a constant, right, if f is equal to c times gx, which is a constant, the f prime of x is equal to c times the g prime of x. The sum rule is that if h is equal to f plus g, then h prime will be f prime plus g prime. Difference rule, similarly, if h is equal to f minus g, then h prime will be f prime minus g prime. Okay? So we're just going to work through some examples. If we have this, right, then by the constant multiple rule, it's just 3 times this derivative, right? And we use a product rule, which is like 15x4, right? B, if fx is equal to 71, this is a constant, right? So the prime will be 0. Well, if f is equal to square root of x, the fx will be x of 1 over 2, which will be 1 over 2 x 1 over 2 minus 1, which is this, which is equal to this, right? Okay. And then we have the product rule. The product rule says that if we have a product of functions, if px is equal to fx times gx, then p prime, the derivative of this product, is equal to f prime of x times gx plus g prime of x times fx. Okay, so remember this formula. So you can remember this as follows: derivative of the first times the second plus derivative of the second times the first. Okay, so this is the way to memorize this better. So we're going to use the product rule, right? So the derivative of this will be derivative of the first, which is 3, times the second, plus derivative of the second, which is 2x, times the first, which is 3x plus minus 5. And then we simplify this to this. Similarly, we have another example for the derivative of this, which is the derivative of the first, which is 2, times the first times the second, plus the derivative of the second, which is negative 1, times the first. And then we simplify to this. We also have the quotient rule. If hx is equal to fx over gx, okay, then the derivative of this quotient is equal to f prime g minus g prime f over gx squared. Okay, so this is a bit longer, but still memorizable, right? And we can apply the quotient rule. So for this expression, the derivative will be, we square the bottom, right? And then we prime the first times the second minus prime the second times the first, right? So prime the first one, which is 3, times the second minus the prime the second, which is 2x, right, times the first, right? And then we simplify to this. Similarly for this one, right, at the bottom we know that it is the bottom squared, right? And for the top will be this prime, which is 6, times this, minus this prime, which is 3x squared times 6x minus 5. And then we simplify all the way to this, and then we factor it out, okay? And this is it for today.